Hello and welcome to the next lecture. Now we will be learning about the labor market equilibrium. So we're going to be putting together our labor supply curve and labor demand curve, and the interaction of supply and demand will determine a wage and employment level, which we will call the competitive equilibrium wage and employment level. And this occurs when the supply and demand is equal. So when we have the labor supply curve and labor demand curve, the intersection point is also called the market clearing point, and that's where the quantity supplied of labor will equal the quantity demanded. In reality, it's unlikely that a labor market will ever be in an equilibrium because there's things that are changing all the time. Supply and demand are dynamic, but you can think of it as sort of a target, a moving target that the market is moving towards. So a market will always be moving towards an equilibrium, but it may not ever get there. Okay, so let's look at an overview here. So in terms of labor supply, we have workers, they're selling their labor on an individual basis. We learned about the labor supply curve. We learned a model that we can derive the labor supply from. We looked at labor demand, and labor demand is a result of firms' profit maximizing behavior. Okay, and so labor supply and labor demand interact in a single market, and that determines the wage and employment levels for a specific skill set of workers. Now, firms operate in the product market. Okay, so they obviously are selling a product or service. They also purchase labor in the labor market. Now, the product market can be either perfect competition, imperfect competition, or it could be a monopoly or oligopoly. Imperfect competition includes monopoly, oligopoly, and monopolistic competition. We can have a perfectly competitive labor market, an imperfect competition in the labor market. We're going to just specifically look at what a monopsony, okay, and we'll look at that later. Today, we're going to look at a perfectly competitive product market and labor market, and we'll also talk about imperfect competition in the product market, okay? So we're going to look at the equilibrium for when the product market and labor market for the firm are perfectly competitive. But today we're also going to assume that perhaps the product market, and so the firm itself, is a monopoly. And how does that change things? And then next time we'll look at monopsony. Okay, so competitive firms demand. So we're going to assume that there's perfect competition in the product and labor market. So some of the assumptions we're going to make are that there's a homogeneous type of labor. Okay, so we're talking about a particular type of labor in the market. Maybe it could be unskilled labor. Now, the firm is a price taker in the product market and also a wage taker in the labor market because they're both perfectly competitive. They can't influence anything in any of those markets. We're going to assume that the supply of labor is perfectly elastic at the horizontal wage. So that's a result of our assumption of a perfectly competitive labor market. So the firm can't pay a wage lower than the equilibrium wage because no one would work for that firm. And if they pay above the market wage, well, they'd just be wasting money because they can hire as much labor as they want at the going market wage. And that's the fourth point here. So again, the firms can employ all the labor they need at the market wage. That's an assumption of the perfectly competitive market. And so, of course, the market wage rate is set by the aggregate labor market. That's what the firm is going to take as given. So here we have an illustration of an equilibrium. So we have labor supply. We have the labor demand curve. The intersection point is here at W star and E star. Now, in equilibrium, all persons that are looking for work at the going wage, the equilibrium wage, can find a job. The triangle P gives the producer surplus, and the triangle Q gives the worker surplus. Okay? And so clearly a market will produce the maximum surplus. Okay, you can't get any better than this. Okay, so over here, if EH level of employment was, if EH was the level of or number of workers that were hired, we'd have an issue here, because here we would have workers that their marginal revenue product is less than the cost. So these would be not beneficial trade in terms of labor that you would want to see occurring in the market. But if anything's below, there would be a benefit for the person working, because you would have that the marginal revenue product would be greater than the costs. Okay, so competitive equilibrium in two labor markets linked by migration. So we're going to think about, well, suppose we have homogeneous labor, but there's two different markets, and the only difference is their location. Okay, so we have a northern labor market and a southern labor market. Okay, and so if we initially look at point A here in the northern market, we have that the wage is WN for wage in the north. If we look here, the initial point is WS. Okay, and so we have a much lower wage in the southern market. Now the question is, will these wages persist in a competitive equilibrium? Well, the answer is no. And if you think about it, given the assumptions that we're making, so we're saying that the workers can be fully mobile, and since the workers have the exact same skill, these workers here, the southern workers, would want to move to the northern labor market because the wages are higher. Okay, and also note that in the north, this higher wage would mean that the marginal product of labor is high here as well, because we're high. Well, if you remember diminishing returns. So if you were just to think of the big picture in terms of efficiency, you would realize that the market. So what's going to happen here is that the southern workers will be attracted to the northern labor market. So we can think of the supply curve shifting to the left. And the wage is going to increase because you have people leaving, and the wage is going to get bid up. And in the north, those people are going to come and enter this labor market and increase the supply. And we would think this would happen until the wages are equalized in both regions. Okay? So what we're saying is that the wages, so this initial point where the wages are different is in a competitive equilibrium. It's not stable. In an equilibrium, things should be stable. The only time you're going to have an equilibrium is if the wage is the same in both labor markets, and then there'd be no incentive for any of these workers to move. And this has lots to say about efficiency, this sort of single wage property of a competitive equilibrium. If you remember, in a competitive equilibrium, the wage is equal to the value of the marginal product of labor. And we see here that firms would move to the regions that provide the best opportunities or the higher wages, and that's going to eliminate regional wage differences. If you were to think about, say, a planner, a benevolent social planner, and that person could do whatever they wanted, what they could do, and let's say assume that they're interested in maximizing the surplus, the overall surplus. Well, clearly they would take workers from the southern labor market where the marginal product of labor is low and put them into the other market where the marginal product of labor is high. And so then you get a higher output. So the overall economic pie is going to be bigger if you reallocate workers from the southern part to the northern part until the wage is equal. That will give you a much larger welfare. And so that's exactly what the market does on its own. So you don't need a benevolent social planner. Okay, so the allocation of workers to firms that equates the value of marginal product across markets is also the sorting that leads to an efficient allocation of labor resources. I'm going to go back to this slide and just point out one more thing. So the total surplus, because the labor supply here is vertical, the total surplus would be, if we were at point A, would be this trapezoid here. Okay? And so when the supply increases, we would gain this much surplus, right? And then in this other market, because of this shift to the left in supply, we would lose this amount of surplus. And clearly, just looking at these two, this is is the same area in both. We clearly see then that A, B, and C is the area or the additional surplus we would gain from reallocating labor from here to there. Okay? Let's talk about the short run versus the long run. Okay, so in the previous analysis, when we're saying that the firm can hire all it wants at the going wage rate, we're really thinking about the long run. Okay? And so there's no need to increase wages to hire additional workers, given that assumption. However, in the short run, a firm may need to increase wages to attract workers, and this is sometimes referred to as a dynamic monopsony. So really the market's competitive, but in the short run, it takes time to hire people. Another concept or another point is overtime pay. Think of overtime pay. So to get people to work for overtime, you usually need to pay them more. Okay, so in the short run, firms may have to pay more to get more work, but in the long run, we wouldn't expect that. So in the short run, they may need to raise their wages to get some additional workers. Suppose the demand curve in the product market were to increase, it's possible that they may face an upward sloping labor supply curve. Okay, but a short run wage increase can be a signal for workers to want to move into that labor market, and when that happens, that will drive the wage back down. Let's look at an illustration. So here we have the demand and supply for labor. Here's our competitive equilibrium wage. Now let's suppose because of an increase in the demand for the product, there's an increase in the demand for workers. Well, that could drive up the wage to W1, but that would entice, so in the short run we could see an increase in the wage, but that would entice workers to go into this labor market because of the higher wage. The wage is higher than the competitive equilibrium. So if there's other labor markets that are using the same labor, maybe this is unskilled labor, those workers would be attracted to this higher wage, and that would shift the supply curve to the right, and people would be attracted as long as the wage is higher than WC. So it would be a long run equilibrium when enough people enter the labor market to drive the wage back down to its competitive level. So in the long run, the supply curve of labor is horizontal, and so the firms take this as given, this market wage. So just a distinction between the short and long run. We usually just assume the long run. Okay, so basically the characteristics of a long run equilibrium or the market clearing model, or sometimes called the neoclassical market clearing model, is that workers, if you have homogeneous workers and homogeneous jobs, wages will be equalized across workers. There's an absence of any involuntary unemployment. If there's a surplus of labor, that means the wage would fall and that surplus would be eliminated. There's no queues for jobs or rationing of jobs either. Now, in reality, we know the market clearing model is not, it's not exactly what we observe. The market clearing model, like our model is sort of a benchmark model. We know that the real world's not going to follow it exactly, but it's a benchmark. So when I say here is not entirely true, I'm meaning it doesn't exactly match what we see in the real world. Because wages don't seem to quickly adjust to clear the market. Wages tend to be sticky, and we saw that in the Great Depression. Involuntary unemployment is frequent, and there are large differences in wages across homogeneous workers and jobs. If you can think of different jobs that have the same skill. So maybe if you were to think of an administrative clerical type job, the pay differences could be quite large. Someone working in a similar clerical position at, say, Google might get paid more than someone who is doing a similar job for a small local company. So we do see that, among workers of similar skill, there is large wage differences. And in fact, we're going to look at compensating wage differentials in our next chapter, which will highlight different reasons why you could see wages being the same for similar workers, wages being different for similar workers. But in any case, the model that we're using is a useful approximation or benchmark model. We have a set of given assumptions, and we're saying if these assumptions are true, we should see this. And if we don't see this, it gives us a framework to think about what assumptions could be wrong, and it just gives us a really good framework to better understand the real world. Okay, so let's look at the case where we have a monopolist. So the firm here is now we're going to assume is a monopolist. It's not a firm in a perfectly competitive industry. So now it's a price maker, not a price taker in the product market. Okay, and we're going to still assume that in the labor market, it's a competitive market. So what are the effects of hiring more labor? So the marginal product of labor is going to fall, and that's because of diminishing returns. So if you remember marginal revenue, so now marginal revenue is not going to be exactly the same as the price. The monopolist is the whole market, and they're going to face the market's downward sloping demand curve. So if they want to sell more output, they need to lower their price. Okay, so let's look at the difference between let's take a look more closely at marginal revenue versus the price. So in a competitive market, we had that the marginal product of labor times the price is equal to the wage. That was the profit maximizing condition. But when we have a monopolist, we're not going to be using this price because marginal revenue is not equal to the price. And each time you hire a worker, they're going to give you a certain amount of output. That's the marginal product of labor. And we want to multiply that by the marginal revenue. So we're going to be considering the marginal revenue product, not the value of marginal product. Okay, so in this case, we're going to have marginal revenue divided by, so if we just look at this on the left here, if we were to take both sides, just divide both sides by P, we would get this. So what we want to do is look at this and compare it to this. This is the profit maximizing condition in a competitive market. So if the firm was operating in a competitive product market, this is what you would have. This is for a monopolist. Now let's look at see what the difference is. Well, here marginal revenue divided by the price is going to be less than 1 because marginal revenue will be less than the price, and we'll show that later on. But if you look at this portion here, this is the same thing as this. By the way, this should be an N. I have an L here, but we're talking about labor. These both should be L's, or they could both be N's. But we can see they're the same thing. The only difference between the two is this term here, and we know that it's less than 1. So that's telling us that if we were to think about the labor demand curve, the labor demand curve is going to be more inelastic for the monopolist compared to the firm in a perfectly competitive industry. Okay, and the reason why marginal revenue doesn't equal to the price is because in order for a monopolist to sell more, it has to lower its price. Okay, when you increase output, revenue will increase by less than the price. So the labor demand curve for a firm with a monopoly, with monopoly power in the output market, will lie below and to the left of the labor demand curve for an otherwise identical, so everything else the same, that takes the product price as given, so a firm in a competitive industry. So if you remember, we talked about the difference between the value of marginal product and the marginal revenue product. So before we had that the price was equal to marginal revenue, and so we used the value of marginal product. But here, when we're talking about a monopolist, the marginal, the additional benefit or the additional revenue a firm gets from hiring another person depends on their marginal product of labor and also the marginal revenue. Okay, it's just basically the difference is just what we're multiplying here. So here we're multiplying by price, here we're multiplying by MR. So when we're looking at a monopolist, we're going to be considering this as the marginal revenue product or the marginal benefit from hiring an additional worker. So if we were to think of the labor demand curve for a firm in a competitive market, it could look like this. Okay, so this would be the sum of all the value of marginal product across all the firms. A monopolist then will have a demand curve that's slightly more inelastic, and it's going to lie below this. And that's because of marginal revenue product is going to be falling. So here you're going to have this falling because of marginal product of labor falling. Remember, diminishing returns is why it's downward sloping. But here you're going to have that the marginal product of labor is going to be falling, but also when you hire more workers, you're also making more units, and you have to lower your price to be able to sell those units. So you're going to have the demand curve fall additionally by that fact. Okay, so this is the marginal revenue product of labor. And that's going to fall because marginal revenue is going to fall as you sell more units because you need to lower the price. Okay, so that's the difference between a labor demand curve in a competitive industry and a labor demand curve in a market structure where the firm is in a monopoly. So the monopolist will produce less output and hire less workers, and it's steeper and more inelastic. There's nothing in our model to suggest that an uncompetitive product market would imply an uncompetitive labor market. So right here we have a competitive labor market, but we have a monopolist in the product market. There's nothing really in our theory or anything really that you can think of offhand that would suggest that the wage would be higher than the equilibrium wage. If the labor market's competitive, then the wage should be our W star, the equilibrium wage. But we do often see differences in the wage between larger firms and smaller firms. So you could have a large firm and a small firm. They're both hiring the same amount of labor, the same type of labor. Let's say it's unskilled labor. But in the real world, we sometimes see that the wage for the workers in the larger firm is higher. There are some reasons for that. Larger firms are more tend to be more likely unionized, and the union could fight for higher wages for the employees. The workers at larger firms may have better capital or technology, and so they might actually be more productive. They may also get better training, and it's even possible that they have better screening to get really good workers, and it's possible that the higher wages could be a compensating wage differential, and we'll talk about that in the next chapter. But there could be something about, there could be other non-wage characteristics of the job that warrant a higher wage. Okay, a monopolist. So what we've seen is that a monopolist will earn higher profits, and labor may be able to appropriate some of these profits. So that's one of the another reason why you could have higher wages. And monopolists, since they're not in an extremely competitive environment, so they could tend to be less cost conscious and may yield to higher wage demands. They also could be subject to the public image, and it looks good to pay a higher wage. So those are some of the reasons why you can see higher wages if the firm is a monopolist compared to if it were in a competitive product market, when they're both hiring in a competitive labor market. Oligopoly, we'll just talk briefly for a sec. So we know in oligopoly there's a few firms with the vast majority of the market share. So they would be, in terms of the definition of oligopoly, they would tend to be selling similar products. And one of the most important aspects of an oligopoly is this mutual interdependence. The action of one firm affects the other. In our other market structures, we don't have that characteristic. So they may pay higher wages than a firm, everything else the same, but the firm is in a competitive market because, again, they have above normal profits, and some of these extra profits or economic profits can be captured by workers. Now, monopolistic competition in the product market. So what we've looked at up till now is, we looked at perfect competition. So think of perfect competition. Now we're talking about monopolistic competition, and the big difference between the two market structures is that in monopolistic competition, the firm has some ability to increase the price of the product because of how they differentiate their goods. So if they differentiate their product substantially, they got more room to play with they have a slightly more market power because they can increase the price. Okay, so in the short run, they can make economic profit, so it's possible then you might see some wages that are higher than the market wage. But in the long run, because of free entry and exit into this type of market, we would expect any positive economic profit to be driven down to zero. And so then there wouldn't be much of a reason to see higher wages than the competitive wage in the long run. Okay, so now let's look at some technical aspects of supply and demand. So we're going to look at the general equation for an equilibrium and look at how we can shift the curves and do some analysis with this model. So what we're going to do is assume we have a labor supply curve. Okay, so that's NS, so the supply of labor, and that's a function of the wage and something we'll call X. X would be something that would shift the supply curve. The demand for labor is ND, and that's a function of wages as well, of course, and Z, which would be other factors that could shift the demand for labor. Okay, so W NS and ND are endogenous variables in this system, right? There's feedback between them, but Z and X are exogenous. Okay, so they're determined outside of our model. So economic theory would give us, would guide us in terms of sorting out what types of things would shift these two curves through X and Z. So to solve the system, we invoke the market clearing condition, which is that the quantity demanded should equal the quantity supplied. Okay, so we set them equal, and then we're going to solve for W star and N star. We would have two equations with two unknowns. So the results, which express N and W as functions of the parameters and the exogenous variables, are called the reduced form. So when we solve this for W star and N star, the intersection of the two curves, that's called the reduced form. And once we have that reduced form, we can easily simulate what would happen if there was a change in X or Z on the equilibrium. So if we do solve that, and I urge you to try and do this on your own for practice, if we do try and solve them, we'll get this. So if we have a labor demand curve, which is linear, so we have our intercept term plus the slope term times the wage, and then we have for the supply curve, we have C plus FW, and of course for labor demand, B has to be less than 0, it's downward sloping. This is greater than 0 because it's upward sloping. And so just given simple linear demand curves with this functional form, the equilibrium would be A minus C over F minus B, and N star would equal AF minus BC over F minus B. So these are the parameters of the model. So the equilibrium values are a function of these parameters, which we have here. So again, I urge you to solve this on your own just to make sure you know how to get to this point. Okay, let's suppose we add a shifter to the model. So we could just add a coefficient in front of a variable X and another coefficient in front of a variable Z. Okay, and so this would be the model which would allow for shifts in the demand or supply curve. Okay, so this X here would shift because we always draw the labor market in the labor and wage space. So anything else that changes, like X, would be represented with a shift, and same with the supply curve. So if we solved this by setting them equal, and we'd have our two equations, two unknowns, we would get this term here as being the equilibrium wage rate. Okay, so in a diagram, this is our linear demand curve, A plus BW. The slope is going to be negative 1 over B. Okay, we know this is going to be negative. If we were to solve for wage in terms of N, we would see that the term in front of the labor term, or N, would be negative 1 over B. This is the intercept. So if we were to set N equal to 0 and solve for the wage, we would get negative A over B. This is the supply curve. It slopes 1 over F, and again we would get that by solving for W as a function of N and see what's in front of this term here. And the intercept is going to be negative C over D. So if we were to set if we were to set N equal to 0, so this would be 0, and then solve for W, we would get negative C over D. So on a diagram, we have our downward sloping labor demand curve, linear function A plus B times W. Its slope is negative 1 over B. That's easy to obtain. If we were to have W as a function of n, and look what's in front of n, it would be negative 1 over b. The intercept term is obtained from setting n equal to 0, and then just solving for w, and then clearly we would see that it would be negative a over b. Our supply curve, upward sloping, this is its formula, c plus f times the wage. Its slope's going to be 1 over f, and the intercept's going to be negative c over f. So again, this is obtained from setting n equal to 0 and seeing what w is going to be. So if this is equal to 0, clearly then w would be equal to negative c over f. Our equilibrium point would be this, a minus c over f minus b, and the equilibrium amount of labor would be a times f minus bc minus f minus b. Let's talk now about a payroll tax. So this is a tax, and it's very common, that's levied on employers. It's proportional to the firm's payroll. An example in Canada would be the Canadian Pension Plan or the Quebec Pension Plan, or workers' compensation, or unemployment insurance. So whenever a worker works and gets paid, the company has to pay this amount, and it's proportional to how much the worker is paid. Health insurance is another example. These are sometimes called job killers, and this is because it's an increase in the cost of hiring people. So a firm may not want to hire more people because they have to pay these additional taxes. So these are increasing the cost of hiring workers, and so that's why they're sometimes considered job killers. So let's assume that workers are paid the wage W for a unit of work, and firms have to pay W plus T per unit hired. So T is the payroll tax. Okay, and that's going to the government. Now, on the face of it, it looks like the firms would just have to pay that, and they would pay the tax to the government, and then this would likely reduce employment because it raises the cost of labor. That does make sense, and it's partly true, but the actual impact on the labor market means that both the employers and employees will share a burden of this tax, and we'll see why. So if we look at our model, we have the same as before, except we have this plus t in there, okay? If we solve for the equilibrium, well, first, if we just rewrite out the demand and supply curve, we get this. We're going to multiply that b through, okay? And so this term here is going to shift the demand curve, okay? And remember, though, that beta is less than 1, okay? So the equilibrium wage will be given by this, and it's going to be less than the wage before the tax, the payroll tax. And if you remember, the wage without a payroll tax would be a minus c over f minus b. But now we're getting that same term, a minus c over f minus b, but we're subtracting a term here that is positive overall, and so this thing is going to be lower, right? This is negative, that's going to be negative, and so this whole thing will end up being negative. Okay, so let's look at a payroll tax in terms of a diagram. So if there's a payroll tax on the employer, according to our model, that would shift the labor demand curve down by the amount of the payroll tax. And that's simply because for any level of labor, so pick any level of labor, like N0, in order for the firm to want to hire that amount of labor now, the wage that they would have to pay would have to be this much lower, this vertical distance lower, which is the amount of the tax. Because now they got to pay this amount T. So in order for them to want to have the same amount of workers, to hire the same amount of workers, they would have to have it that the wage would be lower by the amount of the payroll tax. Okay, and so that's why the demand curve shifts down. And so the new equilibrium wage then will be W1. Okay, so W1 is what the workers are going to get. Okay, that's what they're going to receive now. They used to get W0. Now the firms are going to have to pay W1 plus the tax. So now this is what the firms will have to pay. And they used to just pay W0. Okay, so you can see here that the burden of this tax is shared between the employers and the workers. Okay, so this is the workers' burden, BC. They used to get W0, now they're going to get W1. And the employer's burden is CD. They used to get they used to only have to pay W0, now they got to pay W1 plus T. And again, this vertical distance is the amount of the tax. Okay, so it doesn't necessarily fall on the party that the tax is implemented on. Now, what if the demand for labor is more inelastic? This could be because of the demand for the good in the product market is very inelastic. There was many reasons we learned when we discussed labor demand why this could be. Well, if we just make these demand curves more inelastic, well, we can see the more inelastic they become, the distance between here and here gets larger while the distance between here and here gets smaller. Let's look at that again. So these demand curves are going to become more inelastic. Right now this is the employer burden, this is the employee burden. Look what happens. So we see that the burden for the firm increases and the worker's burden decreases. Okay, so the more inelastic the firm's labor demand curve, the more the incidence falls on the employer. Okay, what about, oh, this is an example. If we had an inelastic supply curve, what would the effect of a payroll tax be? Well, in this case, the workers are going to supply an amount of labor of E0 regardless of what the wage is. So perhaps they perceive any leisure time, they don't have any value for leisure at all. And so their reservation wage is 0. So a payroll tax assessed on a firm would then be shifted completely to the workers, right? So let's think about what would happen. So if we have the tax imposed, that would shift the demand curve down. But the new equilibrium wage would be W0 minus 1. Let's assume the tax is 1. That's where that 1 is coming from. And so the workers are now going to get this, and the employers are just going to be paying this plus the tax, which is 1, which is W0. So there is no burden for the employer, only the employee. Typically, the supply curve is upward sloping, and so there would be a burden for either one of the two. Okay, let's do some practice questions. Under what conditions might one expect wages to be above the prevailing competitive level? Only in the case where the employer is a monopolist in the product market? Only in the case where a union exists? Only in the cases in which the employer has market power in the product market in cases in which the employer is a monopolist, an oligopolist, or a monopolistic competitor in the output market. Okay, which one do you think? So the answer here is D. So it's not only in the case. Each of these has only in the case. It actually could be in the case where the employer is a monopolist, oligopolist, or monopolistic competitor. Also, so it could also be there could also be a union. We haven't talked about unions, but there could be a union. But this question, each of these says only in the case. It's not only in the cases of these. If an employer is competitive in the labor market, which one of these is true? It has to pay at least the going wage. It has to pay at most the going wage. The wage level is independent of the structure of the product market. It can affect the going wage, market wage, by either hiring more workers or laying off many workers, or none of the above. So any idea? So the answer is A. It has to pay at least the going wage. This is the best answer. We know that if they don't pay at least the going wage rate, they won't be able to hire any worker, given the assumptions about a competitive labor market. Which of the following statements about a payroll tax is true? It generally reduces the quantity demanded of workers. It is borne entirely by workers if the supply of labor is perfectly elastic. It reduces the quantity demanded of workers if the supply of labor is perfectly inelastic, or it is borne entirely by employers if demand is perfectly elastic. Well, we just saw that it's borne entirely by employers if demand is perfectly inelastic. So the answer is A. It generally reduces the quantity demanded of workers. And if you remember the diagram, you'll see that since the labor demand curve shifts down, as long as the supply curve is upward sloping, you will get a reduction in the amount of workers. The quantity demanded of workers would fall. We know that this isn't true. It's not borne entirely by workers if the labor supply is if this was inelastic, that would be true, but it says elastic, so that's not true. We know that this one isn't true because if the supply of labor is perfectly inelastic, we know that it wouldn't reduce at all, because you would be, you have a labor supply curve that's vertical at the amount, so it's fixed. And it's not borne entirely by employers if the demand is perfectly inelastic. Which of the following statement is true? The burden of a payroll tax is paid by workers if the supply of labor is perfectly elastic, by workers if the demand for labor is perfectly inelastic, by both workers and firms if the elasticities of demand and supply of labor are between 0 and infinity, by firms if they are legally responsible for remitting the tax to the government. So the answer is C. By both workers and firms if the elasticities of demand and supply of labor are between 0 and infinity, but not exactly equal to those. So here's a question where you have to work out the equilibrium. Suppose a labor market is characterized by these two linear curves. Here's our demand curve, here's our supply curve. Let's suppose that at least initially x is equal to 0 and z is equal to 0. What is the equilibrium wage and employment and star? Which one of these is true? Okay, so you may want to pause the video and work it out on paper. Okay, so we can work it out as you see here. So our W star is A minus C over F minus B. You remember that from the lecture notes from the previous slides. And so we find that the wage in equilibrium is 22.5. So W star is 22.5. N star is equal to A times F minus B minus C times C over F minus B, and that's equal to 55. Okay, so the answer is W star is 22.5 and N star is 55, and this is what it would look like in a diagram. Okay, now suppose that we have that X is greater than 0. Okay, so we have this shifter for the demand curve that's greater than 0. So we need to just remember now that if the demand curve for labor shifts to the right, what's that going to imply about the wage and employment, the new equilibrium? Well, both will be higher, okay? So the answer is D. Just think in your mind of a labor demand curve shifting to the right on an upward sloping supply curve. We would end up with a higher wage and a higher level of employment. Okay, look at this diagram. And the question is asking us, the burden of the payroll tax depicted is, the amount for employers and what amount for employees. Okay, so what's the burden for employees and a burden for employers? Well, let's look at the diagram. This is the initial point. We got our demand, our supply. So initially, the wage is $6. Okay, now we have this tax, and the tax is paid by the firm. So the demand curve is going to shift down by this amount. This is the amount of the tax, right? Now, the firm, so the new equilibrium is 5, okay? So now the firm is going to have to pay a wage of 5 plus the tax, which is 3. So they're going to be up here at $8, okay? So their burden then is 8 minus what the wage was before the tax, which is 6. So it used to be 6, now they got to pay 8. So the burden on the employer is 2, and before the workers got $6, now they're only going to get 5, so the burden on the workers is equal to 1. Okay, so it's 2 for employers and 1 for employees, so the answer is A. Okay, great. Thank you for listening. Next class, we're going to continue our discussion of labor market equilibrium, and we're going to look at the case of a monopsony, and we're going to discuss a little bit about minimum wages. So have a great day. Thank you.